my dear friends, to this occasion. Thank you for joining us on this wonderful occasion. Now, I would like to call upon Akshay Avante to share with you some interesting snippets from the life of a great man, MV Sir, and the importance of Engineers Day and why is it celebrated.
Good morning. Hope I'm audible.
Yes, Akshay, you are audible. You can continue.
Okay. A very warm good morning to everyone. I'm extremely happy to speak on this occasion. Today, Engineers Day is being celebrated in India and some other parts of the world in the honor of Sir MV. As we are celebrating the day, let us take some time to know the personality himself. Mokshagundam Vishweshwaraya was born on 15 September 1861 in Muddenahalli of Chikballapura district in the princely state of Mysore, now known as Karnataka. His father was Srinivasa Shastri, who was a school teacher, a scholar in Sanskrit, and mother was Venkata Lakshmamma. His primary schooling was from Government School of Chikballapur and high school from Bangalore. Sir MV earned a BA degree from Central College, Bangalore, and in 1880 got an opportunity to learn engineering from College of Engineering, Pune. Sir also received licentiate in civil engineering from University of Bombay. After completing studies, Sir MV got a job as an assistant engineer in PW department of Bombay and later was invited to join the Indian Irrigation Commission. During that period, Sir implemented an extremely intricate system of irrigation in Deccan region, Mushi River, which is a tributary of Krishna, flowing through the state of Telangana. Subsequently, Sir MV designed and patented a system of automatic wire water floodgates that were first installed in 1903 at Khadaswala Reservoir near Pune, and the same plan was also implemented at the Kaigar Dam in Gwalior due to his sheer excellence. Sir also planned and executed Krishnarajasagara Dam in Mandya district of Karnataka. This dam was one of the biggest reservoir in the entire Asian continent, which was when it was built. This dam is also known to have translated the barren land of Mandya district into one of the most cultivating lands for sugarcane, also known as Sakkariya Nadu. Inspired by this well-executed project, the Nizam of Hyderabad sent out a call to Sir MV and asked to design a system to save Hyderabad and Visakhapatnam port from sea erosion, which was well executed. Sir was also a technical advisor for the location of Makama Bridge over Ganga River in Bihar. Sir opted and voluntary retirement in 1908 and later worked for the Nizam of Hyderabad. Then Krishnaraja Wadiyar IV, the Maharaja of Mysore, in 1909 appointed Sir MV as the chief engineer of Mysore state, and it was soon the time for the Maharaja to promote Sir MV as the Diwan of Mysore state in 1912 by considering his excellence in execution of projects. Along with the kingdom, Sir MV took out some of the major steps in the state of Mysore that are considered to have impacted millions of lives. Sir MV was responsible for founding of Mysore Soap Factory Mysore, Mysore Iron and Steel Works, now known as Vishweshwaraya Iron and Steel Limited in Bhadravati, Shumaga district. Sri Jayachamrajendra Polytechnic College, Bangalore, Bangalore Agricultural University, Bangalore, Century Club, Mysore, Mysore Chamber of Commerce, College of Engineering, Bangalore, now known as University College of Engineering in 1917, Bangalore Press, Saravati Hydropower Plant in Shumaga district. A very important part of his nature was his love for Kannada literature and the language. He set up Kannada Sahitya Parishat Academy for the upliftment of the language and the literature. Sir was not only a veteran of engineering but also a prominent idea of economy. Under his guidance, started the State Bank of Mysore, which is considered to have a positive impact on the livelihood. So it is obvious that Sir had been awarded many awards. Some of the prominents are Companion of Indian Empire at the Delhi Darbar in 1911. Sir was awarded as a Knight Commander by King George V during British Empire in 1915. Elected as an honorary life member of Institute of Engineers in India in 1943. Was awarded the honorary fellowship of Institute of Town Planners India in 1953 and the mighty Bharat Ratna in 1955. fellowship from Indian Institute of Science in 1959. Sir MP's contribution has obviously come a long way, not only in the field of engineering, but also by boosting the economy of the region and thereby the quality of the life of the citizens. It is more obvious that we thank and honor Sir MV, but it is more important to imbibe the quality of discipline and foresight from the legend. That will surely go a long way. Thank you.
Thank you, Akshay.
Hello.
Yes, sir.
Yes, Aishwarya.
Yes, sir. So I guess we can move with the lamp lighting.
Arun sir, could you please take over from here? Arun sir, are you there? Everyone, please wait for a few minutes. We'll start with the lamp lighting ceremony soon after. So now let's move on to the lamp lighting ceremony.
Uh,
Light
just a
symbolizes,
minute, just a minute, Aishwarya. Uh,
yeah.
Good morning, sir. So there is a plantation drive going on in our college. So will have to wait for a few minutes to Arun sir to join in. I hope that's not a problem, sir. Thank you.
Aishwarya, you can start. Which sir has joined now.
Yeah,
You
Yes,
can
okay,
start
sir.
yeah,
sharing.
thank
Yeah.
you.
Yeah, okay, fine, sir. So now let's move on to the lamp lighting ceremony. Light symbolizes knowledge and darkness symbolizes ignorance. Knowledge removes ignorance just as light removes darkness. Hence, let's light the lamp to bow down to knowledge as the greatest of all forms of wealth. So now I would like to welcome our Honorable Vice Chancellor, Professor B. Satyanarayana, Registrar Professor Basavaraj PD, and Dean of School of Engineering, Dr. Veeresh GK, and our respected speaker, Mr. Shankar Sharma, to do the honor.
Am I audible to you?
Yes, sir, you're
I,
audible.
I request students to turn on videos so that the Honorable Vice Chancellor can interact you and see your face. Students,
So thank you, sir. Now I would like to request our Honorable Vice Chancellor, Professor B. Satyanarayana, to address the gathering.
So the Dean Faculty of Engineering, Viresh, other faculty members, dear students, today we are celebrating the birthday of Mokshagundam Visvesvaraya, which is celebrated as a Engineers Day. So why we are celebrating this Mokshagundam Visvesvaraya's birthday as a Engineers Day? First you ask yourself why. So what is the greatness of Mokshagundam Visvesvaraya? He is an engineer like others. But if you look at his history, his contributions, his profile, he served in the different positions. He is an engineer, AE, AC, CP engineer, and the one of the Mysore. He moved the country from corner to corner. He traveled many countries. And then he has contributed for the construction of dams, where in the early days, when we got the independence, the country has suffered a lot, even for this food. People died due to starvation. So like that, we don't have any facilities. Our people are lived in poverty. Now, if you compare that, we are enjoying a lot. Many facilities have been developed because of the contributions of the respective governments. And here, that development is due to the contributions made by persons like Mokshagundam Visvesvaraya, Swaminathan, and others. They contributed for the eradication of poverty. The Mokshagundam Visvesvaraya contributions, if you look at his contributions, it contributed a lot. After staying in this country, without going to other countries for his better facilities or comforts, he spent his life here. He contributed for the development of country. With that, now we are enjoying. So like that, many engineers that is at his time, or even his juniors, many people have migrated to the other countries for their own comforts. But Visvesvaraya ji, he spared his time here, he spent his time here, he worked for the development of this country. But that's why today the country has developed. So we are now enjoying many fruits of those contributions. Otherwise, the country even struggled to get this proper food. So that is even Hirakud project, which is the Orissa also designed and planned by the Mokshagundam Visvesvaraya ji. And then the many projects has come. Earlier, we don't have any projects also, that is water storage dams. Now these are come up only due to the contributions of our forefathers, like Mokshagundam Visvesvaraya. Because of his contributions, he is an inspiring figure in the engineering for engineers. He's a very dedicated and committed person. For that one, he was honored with the highest, that is award. That is, he was awarded with the Bharat Ratna. That is the highest award in the country. So because of his contributions that he has contributed, that is presented by the government of India, and because of his contributions, because of his and to inspire the younger generations, that is his birthday is declared as a Engineers Day. Like Dr. Radhakrishnan birthday is declared as a children, that is a Teachers Day. Here, Mokshaguna Vishweshwaraya birthday we are celebrating as a Engineers Day. Just we should not that is celebrate for the sake of celebration. Here we should take inspiration from him. So
Sorry, everyone. There is some network issue over our side. Yes, sir.
Aishwarya,
Yes, sir.
can you
You're
hear me all
audible.
right? Okay. Aishwarya,
Yes, sir.
i- so is there a problem
No,
at
sir.
your end?
My side is right. No problem, sir. I guess.
You mean to say the main meeting connection at the university is a problem?
Yeah, I think so. There is some problem over VC sir side, sir.
this is now we are connecting. Are you hearing my
Yes, sir.
voice?
Yes, sir. You're audible.
Yes, sir. So because of his contribution, one person has done. If you think, you question yourself, when the one person like Mokshaguna Vishweshwaraya has done lot of things for the development of this country, why can't we do? So he has done a lot. So that's why now when the government of India started many IITs, even Mokshaguna Vishweshwaraya also is responsible for the starting of engineering college at Bengaluru, Mysore, like that. He has contributed a lot for the development of engineering, that is to develop engineers. They started engineering colleges because the country needs the engineers and technocrats for the development of this country. Here, the government of India also established the IITs like IIT Madras, IIT Delhi, IIT that is Mumbai, IIT Calcutta, Kanpur. That is, they started, the country, our government of India started the IITs that has produced many engineers. But what happened when the Mokshaguna Vishweshwaraya is contributed for the development of this country? Why not the IITians? But sorry to say that all the IITs which were produced from the great premier institutions, they migrated to the United States of America, to other countries. They contributed to those countries for the development. The America is becoming now rich because of the contributions made by the people like Indians and other countries. As they stayed here, our country would have been developed and would have become a very rich country in the world. So that is many people migrated and for their own comfort. But in those days, Mukhyamantri Visvesvaraya stayed here and he has contributed for the development of the country. So that is why that Mukhyamantri Visvesvaraya is a commitment and dedication for this nation. So everyone should have some kind of commitment and dedication to develop this country. That is we required. We can enjoy our comforts, but at the same time, we should see that the country should develop. If country develops, definitely we will also get the benefit. Generations will benefit out of this. When the Mukhyamantri Visvesvaraya has put up a lot of hard work, he moved from place to place. He struggled a lot for the development of this country. Then that's why today we are enjoying all these fruits. Now we are enjoying. Now we are. You see, we are enjoying. We are even attending this online program because of the contributions made people like Mukhyamantri Visvesvaraya. If we do work, definitely the fruits will be enjoyed by the other people, particularly in the future generation. So for that, every engineer who have come out from the universities or IITs or NITs should stay back in India and create some new things so that we can develop our country. If you look at the Japan, where that was that is many two cities were totally destroyed by the atom bombs during the Second World War, and the Japan has lost is defeated in the Second World War because it is allied with the Axis forces, and its economy has collapsed. But due to their efforts, due to the patriotism, due to their dedication, now today Japan is a rich country that is even donating money or technology to other countries, for particularly to developing countries. We are also importing many technologies from the Japan. So when the Japan has become a rich country, why not we? We will become rich only if our engineers stay back in India and go for the startup. So whatever the knowledge you acquire, you start the some kind of industry. So now the present government is also encouraging for startups and also encouraging the universities and other institutions to start the incubation centers. The incubation centers should provide input to the startups so that we can also start the that is industries by our own. Then you will become the job provider instead of job seeker. So that is we can resolve the unemployment problem if you start in that is industries and if we provide the jobs to the others. So that's why that is every the development of country depends upon engineers. If you do with the commitment, definitely all these problems will be resolved. So for that, when you are celebrating the Mukhyamantri Visvesvaraya birthday as a engineer's day, you take his contributions as an inspiration, and then you also become a like Mukhyamantri Visvesvaraya and contribute for the development of this country so that we can eradicate the poverty in India within no time. So therefore, I am requesting all of you, you try to stay here and do the work with commitment and contribute for the development of this country. With this, I thank the organizers for giving this opportunity. I thanks one and all.
Thank you so much, sir. Shankar sir, could you please mute yourself? There is some background noise over there.
Okay.
Thank you, sir. So we have all assembled here today to get some motivation and to cherish the young minds present among us. So now I would like to welcome our registrar, Professor Basavaraj PD, to enlighten us with his words.
Good afternoon. Aishwarya, am I audible?
Yes, sir, you're audible.
Professor Bhattu Satyanarayan, sir, Honorable Vice Chancellor, Central University of Karnataka, Sri Shankar, and Viresh Kaspegoda, Head and Dean of the Faculty of Engineering, and all my colleagues, students, ladies and gentlemen. Uh, we have already heard our Honorable Vice Chancellor. He drew our attention to the contributions made by Vishwesvaraya to the development of engineering in Karnataka particular and in India in general. I must thank the government of India and the government of Karnataka for celebrating this day, the day of engineers in the name of Vishwesvaraya. Vishwesvaraya was one of the phenomenal engineers that the state or the nation has produced. And as the Honorable Vice Chancellor has pointed out, for his contribution to the development of engineering in the country, the government of India gave away the highest civilian award, the Bharat Ratna, to him. And he is the Bharat Ratna in the real sense of the term. And the Honorable Vice Chancellor has also made an important observation about the migration of engineering graduates to other nations like America. Now, engineers in India have two choices. Either they have to develop their own families or they have to develop the nation. So these two developments can't happen simultaneously. For example, you take the example of any freedom fighter, and they sacrificed, they made big personal sacrifices, family sacrifices, and developed the nation. Okay, so either we can develop the nation or develop our families. So we develop our families, we will not be remembered in history. If we develop the nation, we will be remembered in the history. So Vishwesvaraya, had he developed his family, Gandhi, had he developed his family, or take the example of any freedom fighter, Lal Pal Bal, take any example, they all made personal sacrifices. Now, on this day, I appeal to all engineering graduates in the country to think very seriously about their decision to leave the country and go to America or any other country. What do? You earn money in terms of dollars, and you will have more luxuries, and you develop the foreign country. If you stay back, you can develop this nation, and nation needs you. That's what the Honorable Vice Chancellor has said. The nation needs you, and people of this country also need your services. And remember, the government of India spends a lot of money on engineering colleges. Okay, you spend government money to get the degree, and when you get the degree, then you just go away to America. I know that there are problems in India. Okay, merit, we have to recognize the significance of merit. Because merit is not properly recognized in India, many people go abroad. The time has come for all the Indians to realize the importance and significance of merit. Merit has to be respected, honored, and recognized. And it is happening in India. That is a good sign. So on this occasion, I can only say this and join the Honorable Vice Chancellor in requesting the engineering graduates to stay back in India and develop the country. And we are very happy that our colleagues in the School of Engineering, Viresh Kaspegowda, who is Dean and Head, and all other colleagues are doing their best to develop the engineering department. And the Honorable Vice Chancellor has already informed the school that he is going to open a few more departments in the days to come in engineering. And the university is committed to developing the engineering department and section. On this occasion, I thank the Honorable Vice Chancellor for his very important speech and for his brilliant observations and for his unconditional support to science and engineering and all other branches in the university. I thank Viresh, Aishwarya, Shankarji, and others for giving me an opportunity to participate in this very important program and make a few of my observations. Thank you so much.
Thank you so much, sir. So, as a student, we all have likely taken inspirations along the way from the works and words of a lot of professionals. So, to continue to inspire us, I would like to welcome our Dean, Dr. Veeresh GK, to address us.
Am I audible to you?
Yes, sir, you're audible. So, there is some echo over there.
Yeah, now is it okay?
Yeah, it's fine, sir. Yes, sir.
Yeah. Good afternoon to all of you. Honorable Vice Chancellor, Professor Bhattu Satyanarayan, respected Registrar, Professor Basuraj Donur. Already, Honorable Vice Chancellor and respected Registrar talked a lot about uh, Sir M. Vishwesharaya. On this occasion, my humble tribute to Sir M. Vishwesharaya, who was a prolific engineer and the genius engineer. Not he did a marvelous project across the India, and few to mention are so. For example, without water, there is no life like oxygen. So wherever he worked, he concentrated on building the dams, and a few to mention are one is Kadakwasla Dam, and other is famous Mysore Dam, and other many more dams he constructed. And two things I would like to share with him regarding. So we people assume that he is the icon of engineer. He is not only the icon of engineer, he is also the icon of honesty also. You people may not be knowing when he retired from the government service, then British Empire. So he got offer from the Mysore king to become Diwan of Mysore. Then his mother insisted that to take the charge of Diwan immediately without thinking twice. But what exactly he told to his mother that so on one condition I can join the service of as a Diwan. Then mother said, what is that condition? Mother promised me that you will not ask any relative to, you will not recommend any of the relatives to get the government job in the government of Mysore. So this is what this shows that how honest he was. And also one more thing is so he is not only served India, he also served Sri Lanka, Tanzania, and many more countries. That is why today not only India, Sri Lanka, and Tanzania, in addition to India, are also celebrating Engineers Day. So I don't want to take much of your time because my expert is already there to talk about Sir M. Vishwesharaya. And thank you for giving me opportunity to speak few words. Thank you once again, and wish you all a happy Engineers Day.
Thank you, sir. Now I would like to welcome our respected speaker, Mr. Shankar Sharma, to address the gathering. Shankar Sharma has a bachelor degree from the University of Mysore and a PG diploma from Deakin University, Australia. He has over 31 years of professional experience in the areas of electricity generation, transmission, and distribution in India, Australia, and New Zealand. At present, he is engaged as an independent power policy analyst and lives on the bank of River Tunga in Western Ghats. He has been a strong advocate of high policy model of efficiency and responsibility in energy usage and of environmental protection. While trying to practice a simple lifestyle of low energy footprint, he is also educating sustainability in every facet of society in order to conserve various life forms on our planet. He has worked with Greenpeace India in preparing a survey report, Still Report, on the issue of energy injustice and associated himself with many NGOs in public awareness campaigns on the power sector. Over to you, sir.
Aishwarya, can you hear me?
Yes, sir, you're audible.
Can you hear me all right? Is there anything I need to do at my end?
No, sir, it's perfect.
Okay, now the time is 12:23. Can you please check with Dr. Arun Kumar Patil and other authorities whether the total duration for my presentation would remain as it is, or do you want me to reduce it?
Yes, sir. I'll just inform.
Okay,
Sir, you
you
can go
can
ahead, sir.
check
You can go ahead, sir.
while I
No
can
problem, sir.
start. Sorry?
So please go forward, sir.
No, am I suggested that I need to stick with the same duration as it was originally informed to me?
No, sir, you can take your own time.
Now, what is the duration that is allowed? Because we have started around 45 minutes later, I don't want the dignitaries of the universities like Vice Chancellor, Dean, and others to delay any other engagements they may have.
Shankar Sharma, sir, this is Arun Kumar, sir. You can go ahead, sir. According to the plan, you can
Yeah.
go ahead, sir. No problem.
Okay, that's fine. Thank you, Aishwarya. Good morning, all of you, ladies and gentlemen. On this auspicious day, greetings to Honorable Vice Chancellor, other dignitaries of the university, faculty members, students, and ladies and gentlemen who are all listening to this webinar. Good morning to you all, and good afternoon to you also, because there is some slight delay. My apologies if there was some delay because of the connection problem from my end. Also, I offer apologies if there were to be any problem in my audio, basically because I have a slight bad throat. And Aishwarya, I hope you will be there sitting through the presentation. And if there is any problem, please let me know.
Sure, sir.
My appreciation and thanks to the university authorities, the School of Engineering for the university, and Dr. Arun Kumar Patil in special for providing me this opportunity. It's very kind of him to do that. On this auspicious day, I would like to start with the presentation by offering my humble homage to Dr. Sir M. Vishweshwaraya, whom I would respectfully address in future as Sir M.V. Before we start with the main issue, I would like to take this opportunity to share my humble views on the options available for engineers in India. I specifically refer to the two observations made by Honorable Vice Chancellor, the Dean, and the Registrar. I personally feel that with a huge population of 1.3 billion people in the country, the opportunities for all engineers, even if they are as committed as we are all to work and save the country, there may not be enough number of opportunities in the country at all times to come. So I personally do not think there is nothing wrong in our engineers, young engineers, hoping or aspiring to go abroad, any country, understand either for higher studies, learn their experience, learn their work ethics, learn their technological advancements, learn their human resource mobilization efforts. But I'm sure what the Honorable Vice Chancellor, the Registrar, and the Dean meant was that most of us should come back to our country and offer as much service as possible to our own society while developing our own intellectual abilities, professional skills, etc. So I urge all the youngsters who are listening to the seminar today not to misunderstand what the Honorable Vice Chancellor or Registrar or the Dean has said. What you can see in their words is only their sincere appreciation and sincere concern for the development of our own society. For example, I have worked in the country for about 14 years before I went to Australia and New Zealand. I worked there for 9 years. I gained a lot of knowledge, professional ethics, the discipline or approach, and how to be effective in our own work and all that. And I have come back. So that was my basic, I would say, submission. Now, like all professional segments of our society, the engineers fraternity has an important role to play. There is no doubt about that. As engineers, we should not say one particular profession is more important than the other. Everything is important because a society requires, starting from agriculturists, the professors, to the artisans, and even the doctors and those people who keep our cities and roads clean. So no profession is better than others, or no profession is less than the others. But there is an important difference between engineers and other professions in the sense that the role of engineers can also be seen as directly, indirectly leading to a breaking or making a society because of its critical importance. We will come to that. Now, calamitous projections with respect to climate change. I do not know how many of our young engineers who are listening to the speeches today are clearly aware of climate change. I am sure most of them would have been exposed to that. Most of them would have learned, read, or studied, or even listened to their by teachers about climate change recent years. I am sure the present day engineering students are much more exposed, much more knowledgeable, have a much more awareness to these issues than when I was an engineering student way back between 1974 and 79. But the important thing here is how do we bring the issues of climate change into our day-to-day life and also into our professional life? Basically because the threats faced by the entire humanity from climate change cannot be addressed by any one agency or one country or government alone. It is the responsibility of every individual, including a child. The only difference is a child cannot understand or appreciate all these. So let us start with the engineering students. Now, a primary impact can be from social environmental perspective as far as the role of engineers are concerned. You may ask why. Let us look at an important indication through our constitution. Our constitution, especially the sections 48A and 51AG, say that it is the duty of state and every citizen to make honest efforts to protect and improve our environment by protecting and improving rivers, lakes, forests, and living beings. Basically, what it means is protecting the biodiversity, which involves all these and much more: soil, the water, the ocean, the microorganisms, etc. The reason why I'm emphasizing on this particular clause is that is where our role as engineers should come or take a major position in our society, because as you all know, climate change has basically because of our abuse of the natural resources around us, whether it is forests, rivers, mineral resources, or burning of fossil fuels, or even agricultural sector not being managed properly, or you can also point a finger about even our own animals. We are not dealing them properly. So the entire lifestyle of human beings are the causes of climate change, and we cannot ignore to do that anyway, because that is going to impact us, every individual, every family throughout. And I am sure the youngsters of the today are reading about various related news items from different parts of the world, such as United Nations Framework Convention on Climate Change, Intergovernmental Panel on Climate Change, World Health Organization, or our own government of India's Ministry of Environment, Forest and Climate Change. What are they saying? There have been so many academic reports, scholarly reports about how climate change would impact us, what are the factors increasing the impacts of climate change, what can we do, etc. So that is why the role of engineers have to come into picture, not only in developing our country, but basically doing all that is feasible in order to prevent further disasters. Okay, now most of the professional activities of engineers, you understand, will have one or more impacts on our natural resources and hence on general environment too, whether you consider road construction, building construction, industries, or fossil fuel extraction, transportation, usage, anything, any aspect of engineering fraternity's professional life, including our own life, even if you take the information technology or wider usage of WhatsApp or electronic items like smartphones and computers. Even if these are not managed properly, they can directly and indirectly lead to a lot of climate change impact. You may ask me why. We can come to that later. A simple thing is more and more usage of all these electronic devices, whether it's cell phone, computer, or whatever it is, two things can come up quickly. One is all of them will demand much more material usage, which means the pressure on the natural resources and also the waste management associated with making these computers, laptops, or cell phones, or any other electronic gadgets. The second thing is energy itself, because as you would appreciate, each of these appliances would require energy to make them operational, whether it is even in the manufacturing stage also a lot of energy is required, whether even the waste management of this also would require, certainly more of energy would be required in operational stage. So even what appears to be very benign, for example, IT, what we may think, well, what sort of climate impact it has impact indirectly in the form of energy. So they can also be deleterious societal impacts of what we do as engineers on local communities. For example, there can be forced displacement by large projects, nil or inadequate compensation when we acquire land for large projects, loss of employments for the locals because they are driven out of their places to set up a large factory or a dam or a reservoir or a road or even an airport or a sports ground. Denial of access to natural resources can happen because if you acquire a lot of land on a coastal area, hypothetically, let's say, then the fishermen who are going to the ocean for fishing rights there, they will be barred from entering the ocean from that person because the society has acquired that land for some industrial activities. There can be health impacts because of the pollution of land, air, and water along with soil has reached with enormous proportions in the country. My young engineers would be surprised to know that as per World Health Organization, of the 30 most polluted cities, India has about 22 in our own country. So the pollution of air is very well established, and it will not be an exaggeration to suggest that there is not a single river in the country. India has very huge water resources once upon a time, thousands of smaller and larger rivers, except for one or two in the upper reaches of Himalayas. And I know one river in Western Ghats of Karnataka called Aghanashini or Beddi. Almost all the river stretches, except few stretches in the country. Some people suggest that up to 90 to 95% of the river stretches in the country are so polluted that people may not be able to use that water directly for drinking. We have to process it. So things are pretty bad. The other problem with the forced displacement of people for any large project is the loss of social stability, because many of our ancestors, as we have all come from villages, our ancestors have lived in the same place, same village for hundreds of years throughout their ancestors. Now, if we suddenly force them to move out of that, they will face a lot of instability of losing their leadership qualities and others. So this is the context in which we have to see or consider the role of engineers. Now let's come back to what are the issues. Let us consider any physical work undertaken by engineers, whether on land, water, or air. They will have ecological impacts. For example, I will quote some of the major projects or activities where we can associate engineers. Roads, bridges, railways, dams, canals, buildings, townships, factories, chemical processing plants, seaports, airports, aircrafts or drones, military hardware, storage houses, energy, water reticulation system. Reticulation means supply systems, waste management system, power plants, power transmission lines, even microwave towers, etc. So these impacts in most cases can have long-term or permanent deleterious impact on the environment and also on our community. So that's where our role should come into picture. Now, our role should be, if you ask me what are the main role, Aishwarya, if you have many of your colleagues or classmates there, can I spend about few minutes in asking some of you at least who want to talk as to what do you think is the role of our engineers?
Sure, sir.
I would love to hear from some of you or all of you if you want to look. Can you just take 1 minute from your own side, all of you, if you want to say something as to what should be the role of engineers in the present day society? Aishwarya, why don't you start from yourself?
Yes, sir. I guess the role of engineers, because they need to understand what the society actually needs, then they need to tend according to the, let's say, environmental issue. They should consider every factors on their mind and then tend to it. That's what I
That's
think,
good.
sir.
Yes, that's good. Anybody else?
Good afternoon,
Shall I
everyone. Respected teachers. Yes, sir.
go ahead? Yeah.
Am I audible, sir?
Yeah, I can hear you. Go ahead. Your name, please.
Yes, sir. I am Sandesh Pandey from BTech second year Electronics and Communication Department.
Yeah,
Sir,
go ahead.
role of engineering is an engineer takes a nation in progressive way. One example, what our modern engineers are lagging is, sir, if someone starts a startup, other engineers should support him. He should share his knowledge with him so that both engineers or both startups can come to a good end. What Sir M Vishweswaraya did when he was offered a vice president's post when he was in Bombay that time, at time of Britishers, when other his colleagues were opposing him, what he did, he left the post and supported him. So for that reason he went too far in his life. He didn't struggled among themselves. So if you're not getting opportunity, you can create your opportunity. You can leave job, you can use your own mind, you can think positively, and you can progress in our way. Role of engineering is, sir, rather doing more economic loss for country. He should make best from the waste. We see few TV shows run where engineers show how to create good from scrap things. All such things should be promoted even in colleges. Once in a year, a batch should create something good which is useful for upcoming batches. Thank you, sir.
Okay, that's good. Anybody else?
Sir, we have something in the chat box. I'll just read it out, sir. Nitesh is saying that engineer fulfills the future needs of the society, like development of new technology.
Okay. Shall I assume that nobody else want to add their opinion now? Shall we move on to the next one? Okay. I assume that for some reason, some of you who are youngsters can be chatterboxes. Is it because that the vice chancellor, the chancellor, registrar, and senior faculties are already there? You are hesitant to talk. When you have been asked to talk and you are asked to give your opinion, the primary role for an engineer is should not be hesitate to give their opinion. I am sure all of you would have your own opinion as to what the role of an engineer is. I'm happy three of your colleagues gave their opinion, but you should not hesitate to give opinion as long as they are honest opinion. Anyway, Aishwarya, shall you move to the next stage?
Yes, sir. Sure. Sir, could you please adjust your camera?
Okay. Why do you want to see me? You have already seen me.
No,
Okay,
it's
that's
good
fine.
for interaction, sir.
Okay, that's fine.
Yeah.
Okay, can you hear me all right? Was
Yes, sir. Yes.
my speech is audible and is it clear? Is there any problem?
Yes, sir. It's perfect, sir.
Okay, now let's move on to the role. I would say engineer's role should be to objectively assess the need for the project, its role in society, costs, benefits, and societal impacts. Aishwarya, I don't know whether your colleagues are having access to the PowerPoint presentation slides.
No, sir. We are only able to see it through screen.
Yeah, that's right. Can they see the screen? Can they read out or what?
Yes, sir. The screen is visible.
Okay, that's fine. Now, the other role should be to choose the best option from societal perspective for lowest overall costs and maximum benefits. My dear young friends, we can talk on this particular issue for days together. What I would like to highlight here is when you say choose the best option, you may be wondering what do I mean? Okay, I will give a quick example. For example, I'm an electrical engineer, so most of the time the examples come to me from PowerPoint, power sector's perspective. Let us say we need to, as engineers, some of you certainly would go to that position as electrical engineers in charge of a section. Let's say you want to arrange a power supply to a new installation. Let's say a factory of say a few hundred kilowatts in one below, new factory. Now you will realize that there are number of options to provide power supply to that factory. You have to consider all technologically suitable options, do a costs and benefits analysis not only for the industry's perspective, but not only for the supplier's benefit or cost, but from the society's perspective. What is the best option of providing supply to that factory, keeping the lowest cost for the entire society, whether it is societal costs, whether it is social perspective, whether it is economic cost or environmental cost or even technological cost. So that becomes a very important. I can quote a number of options to supply power to that factory. One is from the existing grid. If there is a nearby power supply point, you extend it to the factory, but you have to do study whether the factory's requirement can be met satisfactorily from the existing grid by just extending a line, or do you have to put a new additional line? Sometimes if the load from a new demand for load may be a few thousand kilowatts, then the existing system may not support it as it is, though you may have to put up another power plant. You have to consider that. In recent years, another option which seems much more attractive is, why don't you consider setting up a renewable energy supply power option in the premises of that factory itself? For example, a factory generally means large rooftop area. Can you put up solar photovoltaic panels on the rooftop and equip that along with the latest protective and communication switch gear along with a backup energy storage battery? So that will make it much more sustainable and probably very economical too, without loading the nearest bar grid. But we may have to look at the cost and benefits, risks, whether the factory requires power supply 24 hours a day or not, whether the area has adequate sunshine, whether the factory requires 365 days, whether they can put up with reduced power supply during monsoon. So you have to consider all these options. So that is why I said the role of an engineer, for example, if you are a power sector power engineer, you have to consider various options as to which option is the best from that perspective, not only for the factory owner, not only for your own client who is a, let's say, a local distribution company, but also for the entire society. So that's why I said choose the best option from societal perspective. It is not just power supply, it can be a road. For example, there is a town and another town, there is a wildlife sanctuary in between these two towns. If a road is to be connected, for example, if a rail or a power transmission line or a microwave tower or a communication line is to be taken from one town to the other town with a wildlife sanctuary or a thick forest or a river or an ocean in between, there can be many options. So you have to look at that option which is least cost to the society. For example, if there is a proposal to take a power line or a road or water pipeline through the wildlife sanctuary, what is the implication on the environment or the local biodiversity or even the wild animals in that? In many cases, if it is a wildlife sanctuary, as per the legal terminology, it's called as protected area under the Wildlife Protection Act. The government or the wildlife board or the National Wildlife Board may not give permission for any activity. That's also possible. So you have to consider all those options, whether it is a road or airport or a ropeway or a mining or industry, even canal. Any engineering task, you have to consider all these options. This is what I want to highlight. Next important thing is ensure compliance with all the associated acts of parliament. There will be act of the local legislature like Legislative Assembly or Legislative Council of Telangana or Andhra Pradesh or Maharashtra or Bihar. Then there will be suitable policies of the government of Karnataka, sorry, government of state or even government of India. For example, there is a national forest policy at the national level. There is the national electricity policy. There can be local policies which may govern a particular activity. Then there are certain standards, engineering standards. For example, roads have certain standards. If it is factory, there are certain standards of pollution. If it is electricity, there are certain standards. And what are the regulations? Regulations may be local, regional, statewide, or even national. There is also need to ensure that environmental damage and pressure are least in all those associated activities. Then ensure wider societal acceptance and peer review. What I mean by this, for example, if you are a chief engineer in a state, let's say, because of your position, if you undertake a project, there may not be a lot of opposition because of the fear of your position, but the entire society should also accept what we are doing there. Without their acceptance, without their cooperation, a project is unlikely to go ahead satisfactorily. Either there can be loss of faith, there can be court cases, there can be forced design changes. For example, the entire society may oppose a route of a road, and you may have to change the design of the route of the road. That will cost more money or more time. So it is necessary and it is always advisable to take the acceptance of the local people, especially local people, and also the domain experts and peer review. There is something called peer review. Your professors and assistant professors will be able to give more information to you on that when the time comes. Peer review is basically, if Aishwarya is an engineer doing some project tomorrow, her work or design should be accepted by her colleagues also who have similar expertise, similar knowledge, or similar level. Without their acceptance, this cannot be peer reviewed. You might have heard about peer review of our articles in journals. That is basically many of the international journals. When you submit an article for such a journal, that will be sent to a few independent experts, and their views are also sought. Only when they also say that article is of certain addition acquired certain quality, a particular journal will publish. Similarly, even in an engineering project also, you have to see that your work is appreciated or accepted by others, especially the peers. So that is also a requirement. And also, most important thing for an engineer is look for a model which has an internationally appealing nature, especially international best practice. There are, for example, you want to set up a factory somewhere, whatever may be the product or the process. There are certain standards for a factory. How much energy you should use per unit of the product control, how many people, what is the energy per unit, what is the number of people for a given amount of output, what is the pollution, how the waste from the, sorry, Aishwarya. Hello.
Yes, sir. It's fine, sir.
So this is the problem in talking or attending to a webinar from a cell phone. I have to keep that on, and somebody can chip in. Okay, sorry. I was talking to you about a model to be emulated elsewhere or matching international best practice. There are something called international best practice for all engineering disciplines, whether it is computer design, whether it is a microwave tower design, or a chip manufacturing division, a road. Every road has certain standard to be met. Same thing, electrical power supply, whether it's frequency, voltage, harmonics, reliability. So you take any of the engineering tasks, there is something called international best practice. So our aim should be to reach that international practice, or even better that, so that our own model can become an international best practice in the long term. So that's another issue. Let us come back to Sir MB's role model. Vice Chancellor, the Dean, and Registrar have spoken very well about Sir MB's role model. One of your own colleagues also spent 5-6 minutes eulogizing what MB's achievement in professional life. So I can also talk about the great man's professional and personal life career for number of hours. But few things come up to me as very, very important. One of the speakers mentioned about his discipline. He was one of the most disciplinarian you can come across in professional and personal life. I will quote few examples. The reason why I am quoting this example is not to appreciate Sir MB's role alone, but are basically to put that as a model for the booming engineers like you. You'll be surprised. His discipline was such a high extent. He used to carry 2 pens with him all the time when he was in the official role. One was for the office use, and the other pen was his personal use. Of course, it was very rare to see him doing any personal work during his office hours. But if there is a need, he used to use that. And they say he has to keep 2 similar pens at home also. Sometimes he used to take files home. Then he never used to use his personal pen for that. He used to use office pen. At the same time, he never used to use his office pen for any personal work. You will be surprised, after he retired, when he was having a retired life after Diwan and all that, he as you know, he lived for 102 years. A report say that Mahatma Gandhiji, who is already known to be a Mahatma, leader of the nation, he wanted to meet him while he was in Bangalore, I think. So he came to Bangalore for work and he sought an appointment with Sir MB. Sir MB agreed for a time, and it's said that Mahatma Gandhiji went 5 minutes late to his residence. And you know, he is such a disciplinarian and he did not worry about anything else. He rejected to meet Mahatma Gandhi on that day. And the even greater appreciation of Mahatma was that he did not feel bad. He went back and he came back again for another appointment next day, 5 minutes early. So this was one of the issues. Now, many professional and personal qualities are worth emulating for engineers in the lifestyle of MB's role. Some of the things I will go to details of environmental concern and social concern in a minute, but before that, what I want to highlight is Sir MB was known to make use all his leave and the leisure time going abroad, and he was not going abroad only to enjoy. He was going there to see the technological advancement, how those societies are making efforts to bring up people's lifestyle to an internationally acceptable, and how poverty is eliminated, how dams, reservoirs, or even factories were functioning in those places. So each time he went abroad, he used to understand a new technology and try to implement that back in India. That was one of the great things we all have to learn from him. So when he goes outside, it is not just for pleasure alone, mostly not for pleasure, it is for understanding. The people call him as everlasting student. He remained a student throughout his life, learning new things all the time. He never hesitated to learn from even youngsters. Now, coming back to 2 important areas as relevant to engineers in today's discussion, as one example of environmental responsibility and another social responsibility, I want to highlight them. One was sorry. Let us look at his social concerns. You all know one of the largest and most important and oldest dams in the country was Krishna Rajasagara across river Kaveri in Karnataka. I want to highlight how social concern came across. We listen to any project is accused of neglecting the interest of the local farmers, local residents, not giving them compensation, forcibly evicting them from their land and all that. Now, when KRS was built, I was told that about 5,000 acres of people's agricultural land was needed for the reservoir, not only for the dam construction, but also for the reservoir. And very important thing here is even today, the official circles say that the example of Krishnarajasagar was the only one where all the displaced people, not only the landholders, but every displaced people in from that project were suitably compensated, and they were all lived very happily after that in the new vocations or new lands given to them. This is a very important thing for engineers, because in many of our projects we may need to acquire some land where somebody is already living. There may be agricultural land, some may be factories, some others shops and all that. But since we are taking those lands for a public cause or somebody else's cause, then it is our bounden duty to give them sufficient compensation, give them alternate lifestyle so that they can at least live up to their own expectations, and if not to better that lifestyle, at least to make a similar lifestyle. The second one is the environmental concern. Environmental concern was, I am referring to one of the earliest hydroelectric projects in the country. You may know the earliest hydroelectric project in the country was also in Karnataka, Shivasamudra. This was commissioned in 1902, I think. I'm referring to Sharavati Valley. You have heard of Jog Power Scheme, which is one of the tallest, largest, and most beautiful falls in the world. It's called a Jog Falls of River Sharavati in Karnataka. Like all of us, when people used to go there and see the gigantic size of the river falling down from the Jog Falls end, people used to say, "Oh, how beautiful!" But when suddenly we visited there for the first time, somewhere in 1908, I think, of course, he was also wonderstruck by the beauty of that falls. But the first statement came out of his mouth was, "Wow, what a waste!" For his engineering mind, the amount of kinetic and potential energy involved in that falls was very, very important to him. He was wondering, "Oh, what a waste, we have not utilized this energy so far." You will be surprised what he did as far as the environmental concern is. Immediately after, the Jog Falls and that area was very, very thick forest at that time. Not many houses near the falls. There are only villages, far and few in between. He went the same day to the nearest district headquarters, which was Shomaga town. So next day, he asked for the village elders of that area to come and meet him in Shomaga. And it is registered that he had a detailed discussions with these local people. He informed them what is in his mind, and he also took acceptance of them to go with the project. That was one of the earliest hydroelectric projects in the entire country. It was called Mahatma Gandhi Hydroelectric Power Plant in Jog. And it's also mentioned that in the project report, on his insistence, there was a very clear statement. I have not seen the report as such. It was prepared somewhere in 1910 or 12, but it is written about that. He has very clearly mentioned, see, the environmental concern of that gentleman, without knowing a lot about the environmental engineering, environmental aspects, the environmental concerns as we have today. Way back in 1908 or 1908, the environmental concern was almost negligible because there was more than 40% of our area was covered by forest. None of the rivers were harnessed fully. There were no polluting factories, and population also was much less. Despite all of that, he made it a very clear point to highlight in the project report that only about 40% of the water flowing through the river during monsoon. As you know, it was very heavy monsoon, say 100 years back. There was very heavy rains in the Malnad area, Western Ghats. And he said only to 40 to 60% of the excess water available during monsoon as compared to other seasons should be used for this power generation, and all other available water sources and water flowing through the river should be left to the river itself. That is one of the highest concerns for environmental protection you can think of. And subsequently, I understand the design of that Mahatma Gandhi hydroelectric station was done according to that uh, instruction. Of course, subsequently, 2 or 3 more projects came across the same river, and we forgot that great instructions. Nowadays, there are many people, many engineers. I'm sorry to say, many engineers and our political leaders who think that any water flowing through the river to the ocean is a waste. They think it's a waste, but it's not. We can talk about this sometime later, why water flowing to the ocean is not a waste, and why none of the rivers can be said to have excess water throughout the year. They may have excess water in some time. That's what flood is all about, but it's not all the time. So these are the two concerns I wanted to highlight about Sir MB's role as very responsible social and environmental aspects of his work. Okay, we have some of the common practical examples for our consideration. Since I'm in electrical engineering, I tend to focus on electrical engineering because I know a bit about electrical engineering. There are civil engineering, new roads, widening, bridges, railway lines, dams, canals. It can be power plants. In power plants, it can be hydroelectric power plant, coal power plant, nuclear, renewable energy sources. There can be transmission distribution lines, substations, and coal mines also. So you look at any of these aspects, there is a very huge responsibility for engineers. Okay, I will focus on some of the 4 examples in order to drive home my argument that the role of engineers should be very important. Let's look at one. Aishwarya, can you show this particular slide? Can your friends see this particular slide?
Yes, sir, it's visible.
Okay, it says some common practical examples for our consideration. Are you in the same slide?
Yes, sir, yes, sir.
Okay, I will take one example, a recent example which I have come through in my own town. There is a national highway number 206 passing through a town, and there is a proposal by the National Highway authorities to widen the road width within the town in order to facilitate ease of traffic. But that means cutting 488 mature, very highly mature trees. For your information, I am living in Western Ghats, a place called Sagar in Shumaga district. It is almost the heart of the Western Ghats in the country. Very good rainfall, thick forests around. So you could expect that a good number of mature, very high value trees are available throughout the district, and certainly it's so within the town also. Now, there was a public hearing when there was a need to cut 488 trees. People raised a lot of concerns. Some of the concerns were the existing road corridor inside the town is not fully utilized. You may ask why. There are the entire area is not metalled. There are people unauthorizedly parking on the road. There can be vendors. There can be small shops built on the existing road. So people ask the question, unless you utilize the existing corridor fully and convince yourself that expansion of road is absolutely essential, why do we even consider expansion? It's only waste of money. There are effective utilization of same will eliminate the need for cutting trees. This is what our argument was, people's argument. There is another important issue our engineers need to understand. Recently, a Supreme Court has, it's called as judicial note. It has taken note of its own expert committee, which has assigned a value of about 75 lakh rupees per mature trees, taking various issues into account. For example, if 488 mature trees are to be compensated by this cost, it comes to around 365 crores. I don't think the National Highway Authority would be ready to pay 364 crores as a compensation for a stretch of 8 kilometers in town. Very strangely, the total project cost allocated for this work right now is only around 10 crores. So this is a very important aspect I would like to drive home to all my young engineers, that when we want to plan for a large project, especially a linear project like transmission line, power line or a railway line, road, canal network, we have to consider the environmental issue. The Honorable Supreme Court had set up a committee to look into all the cost, direct, indirect cost to humanity from cutting of a tree, or how much a tree would give in its lifetime of about 100 years. So the question here is whether your project cost can include this cost, 75 lakh per tree, and will that still be viable? We have to look at that. Second one is, there was another suggestion recently. Karnataka Western Ghats has number of wildlife sanctuaries. There is a small hamlet. People have been living in that hamlet for hundreds of years. That area was declared as a wildlife sanctuary because of the biodiversity richness. Now, those people wanted power supply. Now, obviously, political leaders would go in support of them. Obviously, they also need some primary facilities. The question here is how to provide electricity supply to that wildlife sanctuary. That example, what I am quoting, required around 10 kilometers of additional power line to be laid inside the wildlife sanctuary, which is very thick in forests and wildlife animals. So people ask the question. They say any human work which is not in benefit of the biodiversity will be against the provisions of the Wildlife Protection Act in a wildlife sanctuary. Why can't we consider the alternatives such as solar, wind, bioenergy? You may ask why. Because within the sanctuary's hamlet itself, people are living there. Why can't you give them solar rooftops, photovoltaic panels for individual houses and school? So that will eliminate the need for bringing a line from outside altogether. Why can't you do that? There is another question. See, these hamlets would not have huge population. There may be 10, 15, 20 families in a hamlet inside a forest who have been living there for a number of hundreds of years. Why can't we help them to come out of the forest, give them land, give them all facilities nearby a town, and make them comfortably settled in a new place instead of cutting so many trees? That's the question asked. So this is another example or consideration we may have to take. There is another proposal for a huge coal power project near a river estuary in Karnataka, again in Karnataka itself. This is the reason why I'm quoting them is I was asked to give my own technical opinion on some of these projects. So that's why I know a little bit more about these problems. Now, people said this is a destructive threat to the ecology yesterday. This estuary and a river was very, very fertile with lot of biodiversity, lot of fisheries and other marine creatures, which was a part of livelihood of the locals. And also it was feeding an agricultural land. And all of that, this proposal was for a 4,000 megawatt coal power project, which can be said to be some of the largest in the world. If that project were to come there, that land and the estuary and the river would have been deleteriously impacted. People's livelihood would be threatened, and it's not a good suitable for coal power plant. You may ask me why. A coal power plant, as per classical power plant economics, those who are electrical engineers, please listen to this. A coal power plant is considered to be most economical in nature under two conditions. One is if it is very close to a coal mine or very close to a load center. This proposed site in this case was neither near a coal mine, and Karnataka do not have any coal reserve, and this is a village on the coastal area, and it is not close to a load center. So from that point also, people questioned the location of that site. And also there were some high level cost benefit analysis was made, and people showed to the authorities that the cost to the society were many times more than the compared benefit, and that project was dropped. There is another similar project very close to relatively dry, but it's an agricultural lands. People have been doing agriculture of areas in Karnataka for a mega solar power park. It's around 13,000 acres of land was acquired. And people also asked similar question. That was not very fertile land, but still people were growing some sort of crops there for a number of years. The question here is loss of agricultural land, loss of livelihood, food security. What happens to food security in the long term if we continue to take a lot of lands for these projects, any project? So we have to look at the long-term impact on people also. We are already, nature's various resources are already threatened in the country. There is a strong pressure on the land, water, minerals, air, and all that. So we have to look at that. Now, having 4,000 megawatt of solar panel in a small village would also lead to local heat islanding effect. Local temperature may increase because of the reflection of light energy from these panels. So that has to be considered. And there will be a lot of demand for water to clean the panels or cooling and all that. So a relatively dry area may not be able to supply that. Now, an additional dedicated power line would be required to evacuate the power. Now, the question people asked was, why can't you go for rooftop solar power all over the state with a total capacity of 4,000 megawatt, which will provide other benefits also. And there won't be requirement for any land diversion or water or additional transmission line or ecological problem. So people argued that cost to the society in such a case of distributed energy sources would be much less. But in case of a 4,000 megawatt land based solar park in one area, cost to the society can be much higher as compared to the benefits. So we can go. I can give you a lot of examples also in this case. I have covered larger areas as to how we have to deal with this, but let us come to one specific example. Aishwarya, how much time do I have now? Can you please check and let me know now?
Arun sir?
How much more time for me?
Arun sir, are you there?
Aishwarya, please tell me what is the upper time limit for your Google meeting schedule?
Sir, no, you can continue, sir. No problem. Another 15 minutes, you can continue, sir.
Okay, now it's 1:15. Aishwarya,
Yes,
please
sir.
let me know when it is 1:30. Okay.
Yes, sir. By 1:30 you can wind up. Then
Yes,
we can
sir.
ask for student for interaction.
I will start winding up at 1:30. Until such time, I need to go. Okay.
Yes, sir. Yes, sir. Yes.
Okay. Okay. Now, for the benefit of this is a project which basically is a power project, substation project. I have worked on this project, so I did as a consultant. So that's why I have much more intimate knowledge. I did the project report also. I wanted to highlight various issues, how we approach this project as a responsible group of engineers, or I was leading a team of engineers to do the project analysis. I will not tell you where and all that, because there can be some commercial sensitivities. This is only a 33 kV substation, a old substation in a major metropolitan city, which required an upgrading. What are the issues? Why there is a need for upgrading? Some of the key issues of concern for the client was there are some safety issues, because the substation was built about 50 years ago. A lot of houses and other structures have come very close to the substation. So there is a substation, a safety of operation also inside, because 50 years ago we used to have only porcelain and oil filled equipment, porcelain insulators. There is always an provision for sorry. There is always a scope for explosion of a transformer, old transformer, or bursting of insulators that could have hurt people in nearby houses and schools. There is also a school nearby. There are some operational issues. There are environmental compliance costs, because the buildings have come very close to the substation. If there is a blowout of a transformer, there can be fire, there can be smoke. So that would have helped impacted the other people. So there is an environmental compliance cost. There are, of course, financial costs. Space were not available easily. There are some public liability issue. See, I'm listing all of these problems basically because as engineers, we have to be aware of these things. Public liability, you ask how public liability may come into picture. If there is a fire, if there is an explosion, if there is a huge fire in the substation because of oil and all that, as you know, a substation would have transformer, lot of oil. If they burn, that may be give smoke, and insulators may burst, and that will impact the local people. They may file a case on the substation authorities. So we have to be aware of that. So we have to reduce the chances of risk for the local people. That's where public liability come into picture. There are other issues of concern also, difficult access to fire brigade. Because of the houses have come up, if there is a fire accident, The fire brigade could not go inside the substation easily, or even ambulance could not have gone there. There was absence of emergency space. This is the old substation, and the manufacturer from which the equipment was purchased might have gone out of operation. Space were not available, so that was an issue. There was a reduced reliability issue, and also there was overloading of the substation because a lot of load has come onto the substation that could not have managed without the expansion of the capacity of the substation. There are some elements of international best practice also were considered. As a matter of fact, now more and more there is a opportunity for unmanned operation, which means a substation or even generating station. I have worked in Australia and New Zealand. There are substations, generating stations, which are operating without a human individual available on the site. There will be one or two technicians who would be monitoring various parameters through a laptop from a distance, and the substation will be operating, or generating station also will be operating on its own. Only when certain parameters exceed a set limit, he will do either he will try to attend to that problem from a distance, or if necessary, he would be available in with a vehicle. He would go there and set it right. So unmanned operation was a key necessity. So we considered that this existing station had a lot of people working on that. Advanced switchgear phase technology, reduction and elimination of oil. See, for engineers, please remember, transformer oil is highly inflammatory in nature. It also is a chemical, it's a mineral oil. So there is always a threat to protection of environment and also local population. So consideration should be given to reduce or completely eliminate oil. It's possible. There are dry transformers available. Then gas insulated switchgear is available, so you don't have to have oil at all. Then elimination of porcelain is another issue. Initially, all the insulators in transmission line or electrical equipment are all porcelain that can break over a period of time. Even a small stone thrown by a child can break that. Lightning can also lead to porcelain breaking. So there are other technologies have come. Polymer insulators have come in place. Porcelain, we can consider that. Vastly increased reliability was the necessity of the day. Few, say 15, 20 years ago, if power supply was lost for half an hour, nobody would have complained. Now it's not so. Higher reliability is an issue. The training of people in advanced technologies, capacity enhancement was also, because that substation has remained to continue to feed the local people, and the load in the local area has come up. The station, 33 kV substation, the capacity was only around 10 MVA. Now, the load on the substation was much more than that, so there was a need to consider the increase of the substation capacity also. So what are the main areas we discussed? Say, minimum cost operation, say for this company for which you are providing consultancy, reducing the cost option by use of the existing structure and most of the existing equipment was necessary. Modify the existing building only suitably to house all the new switchgear or any replacement switchgear, or what shall we do with the new outdoor transformer? Shall we use them, or shall we go for a different technology altogether? Shall we construct a different two-level building to all the household switchgears and transformers indoor? Is it possible? Obviously that would be the best thing to do, but is it possible? We have to look at that. Then construct a single level building also, whether it's possible to put all switchgear and new transformers in one blade, or shall we look to go for GI substation, which is gas insulated substation for all switchgear, which will make it much more reliable. That is another issues we consider. There are so many other various factors we considered also. One of the things we consider, as I stressed initially, was to always keep in mind how to make our work of an international best practice or world-class substation, for example, world's best practice. We should always aim to go to the best possible scenario in any given situation and see whether the world's best practice can be adopted in a new, for example, when you construct a road or a building or a factory or a power plant. Why can't we look at all the options available and choose the best option, including the world best efficiency, the safety, operations ease, and all of that. So we have to consider that. So we try to look at all those issues. From the client's point of view, there are other issues. Optimal use of the existing space equipment, addressing the local issues and making the substation future-proof. What do I mean by future proof? We have to plan such a way, we have to take into consideration that this substation cannot become outdated or unusable in next say 15, 20 years. Usually these electrical equipment are all designed for about 25 years of economic time. So for about 25 years, there should not be any need for replacement of them. And preferably go beyond 25 years, 50 years and all that, because that will reduce the amount of interruptions, that will also reduce the additional cost. Then we also looked at the inspection of existing grid substation. We had a close look at that. We also
Shankar sir, you muted your mic.
Sorry, sir, there was some glitch in the meeting. Can you just unmute yourself again?
is it okay now?
Yes, sir, it's fine.
Okay.
Thank you.
Now, I think by mistake, my fingers went to that particular button. I was looking at what did we achieve by have a close look of the existing station. That was very important, because in order to do any enhancement or repair or changes to a substation, all issues within the substation has to be closely inspected, and the concerned operating or owners have to be talked to in details and look at all other surrounding issues. So we did that, and we listed quite a few issues under risk categories: unsafe working conditions, difficult operating conditions. That substation was in two levels, ground level and first floor. So one operator could not have easily access that. That is an operating condition. Environmental complaints issues was there, financial issues because of the non-availability of space. The financial issues were there, frequent shutdowns is happening. So a lot of financial issues for the ownership. Then public liability issue, as I have mentioned. What we did was we had brainstorming, that is discussion with our own people, the owners, and also it's called as domain experts. The people from the same organization who have a decent idea of this, or people who have worked on similar areas, even from academic issues. So this is what you can look at, that is summary of costs and benefits. We did a cost and benefit analysis of what are the options we have. As we have mentioned here, we look at number of options, and we look at 6 major options. Air insulated substation, option 3, GIS glass insulated, option 2, option 3, and the mix of air insulated switchgear and gas insulated switchgear, option 1, option 2, and option 3. You may ask, what is the cost benefit analysis? Cost benefit analysis is a tool where all the direct and indirect costs of that project are all compiled, they're all captured to the best extent possible. And what is the benefit coming out of the project also for the next 25 years, for example. So that is the design life of normally an electrical equipment like a transformer or a circuit breaker. So what is the benefit the owner or the society can get for the 25 years? What are the operation maintenance cost for that equipment for the 25 years? What is the capital cost? So we have to look at all of them and do through an Excel sheet, you can bring up all of that. So as the first row on the top say, total cost, this is the primary cost. So there are different costs. You can see the fifth column in that last but one column, I have highlighted in bold and yellow. Can you see there, Aishwarya? Hello?
Yes, sir. Yes, sir.
That yellow
Yes, sir.
column is the one which I have marked as highlighted, basically because to drive home that we did costs and benefits analysis for all the 6 options, and we found that that particular option is the most beneficial option. I will explain to you why. Now, base cost, when you do that, have you heard of NPV? You might not have heard of NPV, those who are in the first year and second year. It's called as net present value over 25 years. That means if you spend certain amount of money now for a project, and that project operates for 25 years, you look at the total cost from the project for 25 years, look at the total benefits also. What the difference of the two is called the value of the project to the owner over a 25-year period is called as net present value. As you can see, the net present value for that mix option 2, which is in yellow, is 716.65. It's just a number. Look at all other options, they're all much below that. Now, IRR is internal rate of return. What is the rate of return for your investment for the project in 25 years? You will see that for that particular option, the rate of return is 10.5% on an average per year compared to all other options which are less. Now, there is something called sensitivity analysis. The necessity for sensitivity analysis is because of the uncertainty associated with the costs and benefits. For example, at the stage of design, you may assume certain costs, but by the time the cost, the project is implemented, costs would have changed. Either it might have reduced or increased. Same thing, benefits also could change, become more or less. So we do a sensitivity analysis. Under sensitivity analysis, what we do is, case 1, as you see here on the left-hand column, we will increase the cost by 10%, all the cost of the project. Then we look at again the net present value and IRR. You can see even under that situation, the option mix option 2 has the highest NPV and highest IRR. Next case is we will reduce the benefit only by 10% from the base case and again consider NPV and IRR. You can see again the yellow marks say that the mix option 2 has the highest net present value and highest internal rate of return. Now, as another sensitive case, what we also do is we increase the cost of the project by 10%, at the same time reduce the benefit down by 10%. That means this is the worst scenario you can imagine under normal circumstances. Under that case also, we see that IRR for this mix option 2 is 3.7%. That's the highest internal rate of return among all options, and the net present value is also high. So this is how you have to do all this cost option. My young friends, I would like to draw your attention to another basic issue in our life. Let's say we look at a case of a villager. Let's say a farmer who have only 2 or 3 acres of land. He has a small house there, living with his family. He's not very rich, at the same time not very poor also. Now his family size increases. He has more children, grandchildren, granddaughter. Some of the family members ask him to, we should have a larger house. Do you mean to say he will immediately buy a house or go to a big house? He will do all these cost and benefit analysis, what you are talking about now. He will consider whether this house is big enough or not. If it is not big enough, can he make some of the alterations to the existing house? Does he need to change some internal arrangement? Does he need to build only one room? Or shall he have to increase, construct another floor? Or shall he need to buy another house? He will consider all of that, even though he is not a literate or engineer and he has not done that. So keeping that in view, is it not much more critical for engineers when we are attending to a large scale project of societal importance? We may have to spend millions and millions of dollars or crores of rupees on a project, public project. So we have to be very diligent on all these, looking at all these issues, social issues, environmental issues, cost management. So that's why this cost benefit analysis becomes very important. See, as you have seen, it has covered so many areas and it has reduced the risk of uncertainty in the cost. So I urge all of you to keep this in mind and try to apply that in all your aspects of life, whether it is personal cost, whether you want to buy a house or buy a car or join an engineering, say if you want to go abroad for a higher education, you have to do the cost benefit analysis for yourself. So we have to do that for every project we come across, even if it is changing your table and chair in your office to a new table and chair, or if you have to shift to a larger room in your office, then you have to do cost benefit analysis. That may not be as rigorous as this one is, but you have to do as much as possible. Okay, now Arun Kumar, can I take another 15 minutes? Dr. Patil, Aishwarya.
Yes, sir. Arun sir, are you there? Sir, it's fine, I guess, sir.
Okay, I will take another 15 minutes. I will wind
Yeah.
up this so that we can go to interaction. Now, Aishwarya, you are from which discipline?
So I didn't get your question, sir.
What is your engineering discipline? You are from which branch of engineering?
Electrical engineering, sir.
Okay, that's fine. So, what I have explained all this time, was that clear, or is there a lot of questions at this stage before I move on to the next one?
No, sir, it's quite clear.
Okay, now I have taken 2, 3 examples, 4 examples initially, and then I did the cost benefit analysis in much more details. Now, I want to highlight, I understand the present student audience also includes engineering students from other disciplines. So I will take up some other issues also quickly. For example, I list quite a few, around 10 projects across the country in recent years, which have ran into serious difficulties for various reasons or oppositions. There have been cost and time overrun, and some of them have also been cancelled for various reasons, even including court intervention. Some of them are, it is Lavasa town project in Maharashtra. Somebody wanted to build a new township of luxury homes, and that ran into difficulty. It was through intervention of the Supreme Court, it was cancelled, and a lot of money was spent. People who have invested money lost the money there. Hubli Ankola railway line in Karnataka, there's another problem. It's also gone into a lot of difficulties, controversies. There is a Mysore Bangalore infrastructure corridor, also had a lot of issues. There was many controversies, including court cases. Then multi-storied residential towers are being left, right, and center in many lake beds in Bangalore, and many of them have been ordered to be closed or pulled down. There was a Bedti hydroelectric project in Karnataka that was actually shut down. There is another ultra mega power project in Karnataka that was also cancelled. There is another thermal power project in Karnataka in a thick, rich green forest that was also cancelled. Now, you know, there are Char Dham, Gangotri, Yamunotri, then Badrinath, Kedarnath. Interlinking all these 4 projects in Uttarakhand, there is a highway project proposed by the government that's also having a lot of difficulties and opposition. There are numerous hydro projects in Uttarakhand, Himalayas, large-scale hydro projects in Assam and Arunachal. They're also facing a lot of difficulties, delays, opposition, court cases. And of the latest project proposal, interlinking of rivers. This is the concept. Probably, if you have time, sometime later we will talk about that. But that's also running into difficulty. My take is, all these are only small number of projects I wanted to tell you. They have all ran into difficulties or cancellation or cost time overrun because we could not comply with all the requirement of the project design at this stage, as what we have discussed. The associated reasoning could be the non-compliance of one or more of the project design considerations. I think it's mostly number of violations of the project compliance issues. What I would like to highlight is, by diligently following all the project design considerations as we have discussed, enormous cost to the society can be avoided because of the delays, cancellation, or it can be even minimized. Sometimes we may require a design change that can also be done. So, summarizing, as responsible engineers, we should be conscious of social and environmental costs. And in addition to project and economic costs, we should also be aware of social. What is the cost to society and environment? Be aware of the relevant acts of parliament, rules, local acts, relevant standards and local regulations. And we have to take people's consideration, people's views into account. What are the technological options available throughout the world, or it's available for us in India. We have to be aware of that. Diligently consider all suitable options. We should not have any ego in this regard, because just because I decide something that should go ahead, we should not have that sort of ego. We should be open to consider all suitable options to determine the best option available to a given circumstance in a given place. We should not be hung on our ego or false ego and all of that. The objective is to achieve the best possible solution to our society, and also look at whether we can make that project according to the global best practice. At the same time, we should not hesitate to consult our peers, that means our fellow engineers, or the domain experts or academicians if necessary. We should not hesitate to consult all stakeholders. In a project, there can be a lot of stakeholders. Your client, the consumers, the people around you, the legal authorities, nearby farmers, villagers, fishermen. There can be a lot of people who are impacted. So we should be able to talk to all of them and convince them the importance of that and also take their feedback. We should not hesitate to accept design changes. Once we do the design, if there is a problem with the design, some for your colleagues or somebody say, give an suggestion to improve that, we should not hesitate to consider that if it is necessary or advantageous. At the same time, we should not worry about the grand nature of the project or name for ourselves, but we must look at the societal costs and benefits. And we should never ignore the safety, sustainability, and acceptability of the proposal. Now, there are two books which can throw light a lot of information on this, what I said. Basically, it's on the power sector. These are the, Aishwarya, can you see that? Okay. Now, hello?
Yes, sir, it's visible.
Now, I have listed given the link, web link for two power related books. They're all PDF format, e-books. It's available free of cost. They are available on the website mentioned there. And PDF version is also available with Dr. Arun Kumar Patil. I strongly urge all of you, especially electrical engineers, to go through that. And if there is any issue you want to clarify, you can send back your comments, you can question to me, should not hesitate to talk to me. That will give you a very good basis as to how we can approach a problem in power sector. I think I wanted to talk about in detail about how did we do economic modeling for a hydroelectric project. I don't think we have time. We can, if necessary, we can come back to this if there is a question and there is a time. Otherwise, we can take another opportunity. I will skip that at this stage because we're already running out of time. Now, this is all what I wanted to tell you. I would strongly urge all the young engineers to be aware of your own social and constitutional responsibilities and do your best. Don't hesitate to gain knowledge. Don't hesitate to talk to your fellow engineers and others and do what you can do. I would thank all of you for having been patient to listen to me and giving this an opportunity. And if you have any questions, I will be happy to address them. Thank you. Thanks, Aishwarya. Bye.
Thank you, sir. Thank you so much. So today we had such a wonderful opportunity to hear your thoughts, and this will surely help us in our future events. It's a pleasure to have you here with us, and we look forward to seeing you again for many upcoming events. So once again, thank you so much, sir, for this inspiring session.
Are there any questions now?
Yes, sir. So let's have a small student discussion session. So if you have any queries, you can directly ask, sir. You can put it up in the chat box.
Hello, I am Supriyo Kapas. Yeah, actually, I want to say something that.
Can you please identify yourself?
I am Supriyo Kapas, student of MTech Power and Energy Engineering.
Okay, Supriyo, go ahead.
Yeah, actually, in case of climate, there are some factors, 5 to 6 factors like temperature, humidity, precipitation, cloudness, wind, solar. These things affect climate, and till now we can predict only 6 to 7 days of climate, and beside that it changes so regularly we cannot estimate what will be happen in case of climate. So in everything, when we develop anything, we have to think upon sustainable development in case of energy and power, everything. So that's why unconventional energy sources are become very much important to us, because in conventional case there are lots of pollution and many things. In considering these things, or every thing has been developed, but unconventional things are required nowadays to develop any country with their power and energy. So for that, any unconventional things or any unconventional changes does not come so easily. It requires a lot of social, public, and also many other things. So in nowadays in engineering colleges and everywhere, there are not so much infrastructure to cultivate those things. In engineering is a lot more practical things than theoretical. So in these types of unconventional things, if we want to develop, then uh, these things has to cultivate more, and for that infrastructure and lot of practical implementation with public awareness, it is very much important. So I think, yeah. uh, once
Was there a question or were you making a statement? Please let me know what
yes,
is
sir,
your question.
yeah. No, sir, I was
It's a
making.
comment. Now,
Yeah.
you are correct. There are issues, but please remember the so-called conventional technology power grid as we have in today, it has taken more than 100 years for that to develop or come to the maturity stage as you suggesting now. But are we not able to give even 25 years for the new technology? The question is, have we considered everything is possible? You are asking about 7 days of projection of wind and solar. What about the storage? Can you not storage have energy storage batteries? And you also know that solar photovoltaic panels can generate electricity even during rainy season. Even when it is raining, it can generate electricity. Only thing is it requires some sunlight. So even if it is raining during a daytime, a solar photovoltaic panel can generate electricity, but its capacity will come down drastically. So you are correct. So there are so many options. There are pumped storage hydropower plant. See, we are not looking at this stage, we are not looking for 100% power supply from renewable energy sources. We have to move slowly and quickly away from the existing conventional sources. What is the effort we are doing that? Okay, let's take your own personal house. You must be, your parents are there. Can you not have solar photovoltaic panels on your house top, meet all your requirements, and have a small energy storage device at the bottom of the house for battery, fail say 3 or 4 hours? That should be good enough. Why can't you shift most of your electrical loads like washing machine, if you have, or mixie, grinder, and all this during daytime, so that the daytime solar power meets all your energy requirement and minimize your energy requirement during the off night hours, off light hours. For example, you can keep only light, TV, and computers. Why can't you shift all other applications in the daytime? It's possible. There are so many examples. I can give you example. For example, I have gone to a village in Gaya, near Gaya in Bihar, where they have two villages have installed adequate solar panels on the top of a government primary school in the village. They have enough battery system. All the energy needs of that village is met by that. Let us not remember India is blessed with a huge amount of solar. For around out of 365 days, on an average, India gets around 320 to 330 days of sunlight. So we must make use of that properly. We must make efficient use of the energy. We must make modest change in the lifestyle we have. It is possible. But you have not addressed why. Shall we continue with the conventional energy sources with all climate change implications, pollution, and all of that? We can't. So we must make efforts how to go ahead with the new changes in the renewable energy. There is a tremendous potential in that. Please go through the discussion papers as I have mentioned in my book called Tamil Nadu Electricity Power Supply and Demand for 2050. Okay, next question.
Sir, what about C technologies? There are actually, in case of India, there are three. In three sides there are C. So in case of that things, web technology and those things have not developed so much.
Sorry. What is C technology you're referring to, please? What is C technology?
I am saying about wave energy or.
Okay, C, ocean energy. Yeah. That is. This is there are so many options available. Now we can talk about that later, but there may be other friends also who will be asking question. To answer your question, ocean technology has not developed fully, but a lot of experiments are going on. There is Indian Institute of Oceanography in Goa is working on that. There are many technology which is already in proto size. So now the question here is why don't we encourage them to do that? I have my own friends in the coastal Karnataka who have developed some technology. They are waiting for public to invest money in their technology. So there are options. But before that, let us worry about maximizing usage of already well established, mature, and commercially available technologies, which are hydro, you can leave out hydro because that has a lot of environment implications. Solar, wind, and bioenergy, biomass. India is a country of agriculture. There's a huge amount of biomass. Our electricity can be generated through biomass, locally available biomass at a very low cost. Why we are not investing on that? What about solar photovoltaic? What about the wind? The small size wind turbines can also operate, and in conjunction a solar, a biomass and wind energy technology for any community can meet most of the electricity requirements for 95 to 98% of the time in a year. This has been established in India. Okay. Any other questions, please?
Sir, I guess there is a question in the chat box. So Nitish Kumar is asking if is there any fault in a power system?
What do you mean by that? Sorry, it's not clear. There
Yes,
are always
sir.
faults in a power system. See, as you know, as electrical engineers, you know, a modern network is a very huge network of generators, transmission lines, then consumers, applicants. So many people are working there. The lines are running all over the country. A small child may be flying a kite, and by rainy season, that kite may get entangled to a transmission line, and transmission line can trip. That's a fault. But the protection also has improved tremendously. The protective equipments are very sensitive. They can clear that fault in few seconds, and that's why there is a necessity to have redundancy. That's why once you go to the final year, you will study power system analysis. There is something called N-1. If you have N number of generators and transmission lines in any given time, you must design it such a way that one of the line or generator should, even if it trips for any reason, the system should operate satisfactorily. That is N-1 consideration. You will understand, those people who are in final year or power system studies will understand. But we can plan that with N-1, we can plan additional backups also. Okay. Was that an answer to that question? Ashwarya, do you think that was the answer?
Sir, I didn't quite understand what you meant by that question.
Okay, that is the question. Okay, next. Any other questions, please?
Any other questions, guys?
Okay, it appears all of them. Okay, what are the
sir,
channels through which the residents can oppose to any Okay, I wonder whether it's a question falling into the present. There are a lot of channels. Instead of using the word protest, I would suggest that all of you should consider a project from a holistic perspective, the technical, social, environmental, legal, economic issues, and you can write an analysis on that and write to the concerned authorities asking for clarifications. I think as students, instead of looking at protesting or going for a movement, you should learn to how to analyze the situation, come up with alternatives, ask questions of the concerned authorities. For example, as long as you are students, if you come across a problem, why don't you discuss with your friends first and then talk to your professors and teachers? Come out whether your questions are genuine, whether there are any credible answers, how to raise this question. So there are so many channels where you can air your questions. I will restrict myself, and it is not in the interest of the student community now to talk about all those issues. Let us restrict what as you can do as students now. But once you come out of the engineering college, when you go to the life, there are so many issues. Once you come to that situation, you can send me a private email or call. I will let you know what we can do. Okay, thank you. Next. Aishwarya, I think all your friends must be feeling very hungry, very close to lunchtime. I don't want to push you all. If you don't have any questions, I have no problem to end this session. Aishwarya is left to you and Dr. Arun Kumar.
Okay, sir. I'll just take it.
What about Arun, did you talk to Dr. Arun Kumar? Is he still online?
Yeah, it's there.
Yes, sir. Yes, sir. I am online, sir.
Yeah, Dr. Patil, do you think that has satisfied the need of the occasion? Is there anything else any of you or your colleagues or your students want to talk to me about?
Yes, sir. Greatly, sir. Thank you, sir. Thanks a lot, sir.
What I can do is, so there might have been a lot of questions to young engineers in the minds. I don't mind coming back to you with on a similar webinar sometime later at a convenient time. So please do not hesitate to ask for anything you like, and you can also circulate my telephone number and email ID to your students, young students, and they are free to contact me any time of the day, any time, either through email or telephone. They should not hesitate. I'm here to help them as much as possible.
Yes, sir. Definitely, sir. Yes, sir. Even I will, if they contact me, definitely I will ask them to, I will give your details and I will ask them to contact you, sir. No problem.
Dr. Patil, you are more than competent to answer all their questions, I'm sure. But in spite of that, if they have anything practical life or any other practical issues, and in addition to what you or your colleagues tell them, please ask them not to hesitate. See, this is one thing engineers should not worry about. They should not hesitate to ask questions. You talk to your teachers. There is a global website available to you. A lot of information is available on that, and you need to know where to look for. So your professors and assistant professors, lecturers can help you. But in addition to that, there is a host of people like me who have worked in the field for 40, 50 years and ready to help you in any way like. So we have retired and they are more than happy to help all young engineers in whatever way possible. So make best use of it and please don't hesitate. Okay, Aishwarya, off to you.
Yes, sir. So, as a token of our sincere gratitude to our distinguished guest, Mr. Shankar Sharma, I request Harshit to share the virtual plaque on the screen. Thank you, sir.
Thank you very much, Aishwarya, all your friends, Dr. Arun Kumar Patil, the dignitaries, staff, and other members of the Central University, Karnataka University at Kalburgi. I wish you all the best in your not only academic career but also in professional careers. I hope there will be more opportunities for me to interact with brilliant youngsters like you again in the near future. Thank you very much.
Of course, sir. Thank you. So, acknowledging the good that you already have in your life is the foundation of all abundance. So, as we come to the end of this gathering, I would like to take this opportunity to thank our respected sir, Mr. Shankar Sharma, for his enlightening talk on engineers' roles. Thank you so much, sir. It was really great having you here today with us. Next, I would like to thank our Honorable Vice Chancellor, Professor B. Satyanarayana, for taking out his time from his busy schedule and joining us here. Thank you so much, sir. Next, I would like to thank our respected Registrar, Professor Basavaraj PD, for his valuable presence. Next, I would also like to thank our respected Dean of School of Engineering, Dr. Veeresh GK. Thank you so much, sir, for joining us here and helping us make this event a successful one. Next, I would like to thank all our faculty members who all took their great time to be a part of this event and also helped in adding more grace to this event. Last but not least, I would also like to thank all the participants for joining us today and helping us make this event a successful one. Once again, thank you so much, everybody, for joining here, and a very happy Engineers Day to you all. So now I would like to request everyone to turn on their camera so that we could capture this moment to store it as a memory. Please, guys, just kindly turn on your cameras. So I guess we have taken the picture. So once again, thank you everyone for joining in and for being a part of this event. So now everyone can leave the meeting now.
Thank you very much, Aishwarya, your friends, young engineers, and all the staff and faculty of Central University of Karnataka, Gulbarga. I thank you all for this opportunity. I wish you the very best. Thanks.
Thank you,
Bye.
sir. Thank you, sir.
Thank you, sir, Sir Shankar Sharma, sir. Thank you for your valuable time, and all my dear students and IEEE team participants. I thank all Thank you all.